Hi, this is Manoj, and for CS204 Advanced Computer Networks, we have done a project on comparison and analysis of different quality of services techniques in a simulated network environment with different traffic types and analysis of the level of impact it creates as when compared with using non-quality of services. Next. And so in this comparison, we have done the comparison between the priority queuing and token bucket filtering. The priority queuing prioritizes traffic based on the predetermined criteria to ensure time-sensitive application receive preferential treatment and reducing the latency and improving performance in a network environment. Whereas the token bucket filtering regulates the traffic flow by assigning the tokens to control the rate, allowing bursts up to a certain limit while maintaining overall rate limits, preventing congestion, and ensuring fair resource allocation. And the main goal of our of this project was to analyze and compare various quality of service techniques in a simulated environment with a focus on priority queuing and token bucket filtering. The primary objective was to monitor the effects that these techniques have on the network performance metrics like latency, packet loss, and throughput, particularly when the network is subjected to a variety of traffic. And these are the differences between the priority queuing and token bucket filtering. In priority queuing, the it is a quality of service techniques used in a network environment to prioritize certain types of traffic over others based on predetermined criteria. It operates on a principle of assigning priorities to different types of traffic flows or packets, allowing higher priority traffic to be processed and transmitted ahead of lower priority traffic. Priority queuing ensures that time-sensitive or critical applications such as voice or video traffic receive preferential treatment and experience lower latency and improved overall performance. It can also be implemented using variety of algorithms such as weighted pair queuing and custom queuing, each offering different methods of assigning and managing priorities. And priority queuing also provides a deterministic approach to quality of service, allowing administrators to control and allocate network resources based on their importance and application requirements. In token bucket filtering, it's another quality of service technique which is used to control and regulate the rate of traffic flowing through a network based on defined policies and limits. It operates by assigning tokens to traffic flows where each token represents a specific amount of data or predefined unit of time. Uh, Token bucket filtering also helps to prevent network congestion and ensures fair allocation by allowing bursts of traffic up to a certain limit while maintaining average rate within the specified limit. It also provides a probabilistic approach to quality of service where the traffic rate may vary based on the availability of tokens, but still conforms to overall rate limits defined by the token bucket parameters. So this is the network topology that we have used for this project. It includes one router and two switches on either side of the router, and each switch is connected to two hosts. That is H1, H2, H3, and H4. So we have used a total of four hosts and two switches and one router for this network topology for this project. Thank you. And the next slides will be explained by Puneet Singhania.
Hi, my name is Puneet Singhania. So I'll be explaining about the design now. So what happens in the design, our project basically makes use of a simulated network environment to perform an analysis of the impact of two QoS techniques, that is priority queuing and token bucket filtering. So the design includes setting up a virtual network, generating various traffic types, applying QoS techniques, and analyzing the performance metrics. And the network environment is simulated using Mininet. We create topology, as Manoj told, with four hosts and two switches, and where each switch is connected to two hosts and both the switches are connected to a single router. So we have traffic control commands which are employed to apply QoS techniques, and to simulate real world traffic we use iPerf to generate bulk data transfer traffic, and wget to simulate web browsing, and Wireshark is used to capture packets across the network for in-depth analysis. Now coming to the implementation. So the implementation phase of the project involves setting up simulated network environment, applying QoS techniques, generating traffic, capturing data on Wireshark. And now I'll tell you step by step what is happening here. So first, setting up the simulated network, we have a topology script, that is, we have to run Python topo.py, and then we start the network, and then we have to do the application like applying the QoS techniques. So we employ different Linux traffic control commands to apply QoS techniques. And we implemented priority queuing using the prior queue disk and token bucket filtering using the TBF queue disk. And we generate the traffic. Now we are using iPerf to generate bulk data transfer traffic between the virtual hosts. On one host, we started an iPerf server, and while on another, we started an iPerf client. And for the simulation of web browsing, we used basically wget to fetch web pages. And capturing and analyzing of data, as I told, we are using Wireshark for this purpose. And we use the TCP dump here, and we generated a PCAP file that we could later examine using Wireshark. And we used Wireshark's filter and statistics features, using which we extracted relevant data for calculating latency, packet loss, and throughput. Now, coming to the challenges and resolution. So, accurately determining latency was one of the challenge. This was resolved by computing the difference between the packet timestamps using Wireshark timestamp feature. And then thorough implementation and configuration in Mininet were necessary to manage various traffic types, and it was made sure they don't interfere with one another. And the third challenge basically was like ensuring the accuracy of the results required multiple iterations of testing and fine tuning of the configurations. Now coming to the next slide, you can see different graphs which are made for the latency, and this is without quality of service. Then you have with priority queuing, with token bucket filter, and this is for web browsing traffic. So earlier was for bulk data transfer, and this is for web browsing traffic. Same, it is without QoS, with priority queuing and token bucket filtering. So what we can tell looking at these figures is like for iPerf, priority queuing has the lowest latency. Token bucket filtering has a slightly higher latency, while the baseline that is without QoS has the highest latency. So also for wget, prio significantly reduces latency compared to TBF or without QoS. Now my teammate Manoj will explain the other parts.
Okay, so the packet loss, as you can see, it's most of the times we were even for bulk data traffic and for our web browsing traffic, we didn't observe any packet loss. As you can observe in the figures, the for packet loss is significantly lower for priority queuing as compared to token bucket filter. The highest packet loss could be observed without the quality of service, and as you can observe in the figures, for wget or the web browsing traffic, the packet loss varies significantly between the quality of service technique and is quite lower with the token bucket filter. The throughput for bulk data traffic, throughput is the highest when you are using the token bucket filter, followed closely by the priority queuing, and the lowest it's without the quality of services. So that means when we are not using any of the quality of service, the throughput was the lowest. And for web browsing, the throughput is not significantly affected by any of the quality of service used, but shows slight increase with priority queuing. And the next, the conclusion will be given by Punit Singhania.
So basically, what we are trying to say, so we were trying to answer the three questions, like what impact do QoS techniques like priority queuing and token bucket filtering have on networks throughput, packet loss, and latency. So we realized that the QoS techniques do have a very high impact, based for the network's throughput, packet loss, and latency. Okay, and yeah, and also we can use different kinds of traffic here. The second question is how effectively do these QoS techniques function when dealing with different kinds of traffic? So yeah, it has different kinds of traffic, and we are using bulk data transfer and web browsing. And what is the network's comparative performance without making use? So basically, the throughput is not as much good when using not using the QoS technique. But if you use token bucket filter and priority queuing, so it is much better. So, and the packet loss also is reduced by using token bucket filter. So that is again one of the advantages of using QoS techniques, and that is the comparative performance when compared with non-QoS technique, like not using QoS technique. So yeah, that is all about the project. Thank you.
Thank you.